Hello, everyone. This is my final project showcase within KaggleX Fellowship Program, Cohort 4. I'm presenting to you CosmoGemma, enhancing research productivity in cosmology with Gemma. So a brief introduction about me. I'm Sultan Hassan. I have a PhD in computational astrophysics from South Africa. I am a NASA Hubble Fellow at New York University now, where I do research about early universe, modeling the early universe, and trying to see how we can do breakthrough discoveries with AI. I'm very interested in generative AI and the out-of-distribution challenges and robustness, making very robust model. I enjoy mentoring and outreach. I run several programs to help to train next generation of minorities in the field. Very interested in addressing these challenges of climate change and clean water and energy using AI. This is my website, personal website in GitHub, and this is my LinkedIn profile. So let's connect and build a community. So what is the motivation behind CosmoGemma? What you see in this plot, this is a very interesting plot that shows the cumulative submissions, right, as a function of years. Okay, the number of papers coming out and being submitted to arXiv website. My field is the astrophysics, so that's in red. So what you see here by 2021, we already hitting around 800,000 papers in the market. It becomes very hard now to do literature search. It becomes very hard to know the relevant paper. It's even know whether the project has been done or no. What are the possible projects we can do and so on. And when you start a project, you need to think about these things. And that's why it's very hard now to do the literature. So we need something to automate this and help us to enhance our productivity. And that's CosmoGemma, where it comes into play. So this is the chatbot pipeline. So the basic idea, you have three different components: dataset generation, fine-tuning, evaluation, and deployment. So the first thing is that you go to the arXiv. AstroPH is for astronomy cosmology, .co for cosmology papers only, as a starter, as a test. So we go and take the dataset, which is also hosted in Kaggle dataset. I decided to select papers from 2018 to 2022, which is about 3.5 thousand papers that will be used for, that was used for fine tuning. And then for testing, I thought a lot about it actually. And then I thought, okay, let me try to test on papers that came in later than that during that range for fine tuning, which is I went to papers that came through 2023 and then selected the papers which turned out to be 1,000 of them. So how do we generate the data set? Basically, you take all these samples for fine-tuning and testing, you pass them to a combination of LangChain, OLALAMA, and using LaLama 3.1. OLALAMA is just a framework to help you run a large language models locally on your local machine. And you basically I pass the abstract to LaLama 3.1, and I asked LaLama 3.1, can you generate, given this abstract, given this context, can you generate a question and answer pair from there? Right, so I pass all this to LaLama 3. I selected LaLama 3 because I wanted the diversity. I wanted to have a diverse model that generate questions, and I'm going to use Gemma for fine-tuning. So then for fine-tuning and evaluating, we use the accuracy. So we use the fine-tuning sample and testing sample. And I selected Gemma 2 billion parameter model. And then you have to play with all the parameters like the LoRa rank, the learning rate, the weight decay. You run lots of testing. And then you want to increase, you want to have the loss going down. You want to have the accuracy going up. And then after that, I realized that, oh, I got to the point where I have 90% accuracy on my fine-tuning sample, but for testing for papers that came in later, my accuracy is 75%, which is really great. Then you move to the deployment stage where you put the model on Hugging Face, and then you use GradeU to have an application running live, so for the community to use. This is one of the examples that CosmoGemma can do. So it's able to answer questions, multiple choice questions. This is one of the questions that is available online in astronomy in one of the benchmark dataset, and then the model is able to guess them correctly. What is the correct answer for subgrid feedback in cosmological simulations? It can actually help you also to brainstorm ideas for projects, like please list these three ideas, and it's able to give very interesting answers, like using cosmic chronometers or expansion of the universe, or measuring the Hubble constant, which is a debate in our field. So that could also help you to define new projects. An idea which is, I never trained the model to answer multiple choice questions or to brainstorm ideas, but now it is able to do that and hopefully can enhance the research productivity. This is the project links. We have the model card in Kaggle already. We have the Hugging Face. The model card is there. We have the Gradu app running live. Please try it. And then we have the GitHub repo with all the full release of the codes, the data, the steps, the details of how to develop and evaluate CosmoGemma. This would have never been possible without thanking Rainy and Ray for their excellent management, for the KaggleX Cohort 4 community. We have a very nice, friendly atmosphere and caring and supportive. Thank you for being there. Alameddin for being an amazing mentor. Google and Kaggle for their excellent support and funding and generous funding. And of course, Julia Elliott for founding such an amazing program. Thank you very much. Let's try to connect and build a community at KaggleX. Thank you. Bye.